This is lesson 7.11, using inverse trig to find missing angles. All right, so here's the deal. What we have been doing with trig for these last few lessons is when we know an angle is a certain number of degrees, and we're trying to find a side, and we know another side, we use a trig ratio because the ratio of two sides, let's say in this case, it's opposite and hypotenuse, so this would be sine. So we know the sine ratio of a 33 degree angle is always the ratio of the opposite side and the hypotenuse. Well, now we're going to use that same knowledge to instead, if we don't know what the angle is, let's call that angle x degrees, and then say that we know that this side over here is, 11. We can use trig, but in a different way, which is called inverse trig, to find the missing angle if we know the two sides. So how that's going to look, and I'll just be brief on this because this looks more confusing, I think, than it needs to be. But it's saying if the tangent of an angle is x, then all we need to do is take this a right here and this x right here, switch them around, and use the inverse to solve it. Now, again, that doesn't make a ton of sense yet to you, and it will. So we're going to say if we have the tangent of an angle measure, and we know it's a certain value, so tangent is opposite over adjacent, okay? If we switch them and we put the ratio over here and the angle over here, and use inverse, we can find that missing value. It's going to make more sense later. Same thing happens with sine and cosine. We're going to take the a and move it over here, the y over here, and use inverse. Bring the a over here, the z over here, and use the inverse. So inverse, that little -1 is telling us that we're using inverse tangent or sine or cosine. Again, it'll make more sense as we move along. Okay, so let's use that knowledge. I know, like I said, it was a little messy on the previous screen, but this is going to make some more sense, okay? So if angle A and angle B are acute angles in two right triangles, use a calculator to find the measure of angle A and the measure of angle B, round to the nearest thousandth. Okay, so here is the deal, okay? Sine of A equals 0.76. On the previous screen, what I told you is that if we're trying to find an angle, instead of finding a side, we're going to use inverse trig. We're going to take the angle and whatever the ratio is. So it's written as a decimal here, 0.76, because the ratio has been converted to a decimal. But sine is opposite over hypotenuse. So opposite over hypotenuse in this triangle gives us this decimal. Okay. What we're going to be able to do is simply switch these two things around and use inverse trig to find the value of A. So we're going to write sine inverse. We're going to switch these two things around. So I'm going to write of 0.76 is equal to, and the A is going to move over here. We're going to write it as measure of angle A. So if you think about how earlier we have sine of an angle measure, let's say I think I had 33 on the previous screen, sine of a 33-degree angle equals the opposite over the hypotenuse, right? And we would know one of these, we'd find the sine of 33 because we know that's just a number. And then we'd be able to find one of these by solving by cross multiplication. Well, what happens now is, again, we can't take the sine of a variable or a missing angle value. We can't do that on our calculators. Sine of A doesn't make sense. But what we can do is the sine inverse of the ratio and get the angle measure. So grab your calculator, and what you're going to type in here, so you're going to use the shift key on almost every single calculator. You need to use shift, because if you look at sine, look at the sine button on your calculator, and right above it, not the button above it, but right above it on the calculator, it should say like sine with a little raise to the -1. That's sine inverse. And so you're going to hit the shift button to get to that sine inverse. So hit shift and then sine, and what should appear on your calculator is sine with a little -1 like this right here. So now we're going to type in 0.76 and hit enter. What you should find is 49.464 equals the measure of angle A. Okay, so we're using inverse sine to find the missing angle. So we can do the same thing on this next example. We're going to say, okay, the cosine of some angle is this number. Now, by the way, you could look, we talked about this in class previously, we could look at a trig table right now. If you remember me talking about trig tables, we could look at a trig table and find the cosine of some angle. It gives us this decimal. We could find that decimal in that whole big list and find out what angle it is. So it's kind of like doing the opposite operation. Okay, so again, here we go. Cosine inverse. Take these and swap them around. So we're going to put 0.17 here, and then we're going to put measure of angle B here. Now we're going to use our calculators. Shift cosine of 0.17, hit enter, and we're going to find that 80.212 is the measure of angle B. Now, I think the next example is going to clear things up a little bit because it's a little bit more of a traditional trig problem when we're trying to find a missing angle. Okay, so here is a more typical problem. Let's say we have a right triangle. Right triangle. We know this side here is 9. We don't know this side. We know the hypotenuse is 12. And we're trying to find a missing angle. All I know right now in this is that these two angles will add up to 90 because the 90 plus the other 90 would be 180, but I don't know what it is. It could be anything between 0 and 90. So we have to use inverse trig. That is what we're going to do when we're trying to find a missing angle. So I'm going to start this problem the same way as always. I'm going to label my hypotenuse with H. I'm going to say the angle of reference here is the angle we're trying to find. The angle we're trying to find. We don't know either of them. That's the one we're trying to find. So opposite of that angle is over here, and adjacent to that angle is right here. So that same process that we typically use. So now instead of circling the one side I'm trying to find and circling the one side I already know, I'm going to circle the two sides that I know. I know the hypotenuse is 12, and I know the adjacent side is 9. So we look at SOHCAHTOA, and we think to ourselves, which of these trig ratios has A and H in it, since that's what I circled. Notice I did not need opposite here. So of course I'm going to use cosine. So typically I would write cosine of theta is equal to adjacent over hypotenuse. I'm not changing anything here, but now I realize I'm trying to find the angle. I mean, we already realized that, right? But we're trying to find the angle. So we're going to say, all right, the cosine of our angle, we'll call it x because we're trying to find that value, x, is equal to the adjacent side, which is 9, over the hypotenuse, which is 12. Now, once I get to here, okay, just like what we were doing with regular trig, next what we would do is we would put this over 1 and we'd cross multiply. But the problem there is we can't cross multiply and solve when we have the cosine of a variable, because your calculator will not do the cosine of an unknown, because without knowing what it is, you can't compute it. So we're not going to put this over 1 and cross multiply. You have to realize when your x is the angle and you're trying to find the cosine of that variable, you're going to need inverse trig. So this is where we write cosine of negative, or raised to the -1, which is our inverse cosine. And now we're going to take this, and we're going to swap them around. We're going to swap them around. So we're going to say cosine inverse of 9 over, of 9 over 12 equals x. Now we use our calculator and we use shift cosine, and then make sure you do 9 over 12. Most likely has to be done in parentheses. Okay, so keep that in mind. And when we compute it, you should get, check your calculator, you should get 41.410 when rounded. Okay, so check that out, see how it's going. Okay, so let's try a couple more. Okay, we're trying to find the measure of angle A. Here's angle A in this first one. Based on that angle of reference that I'm trying to find, and you can go ahead and put an X in there if you want, or just use A, we're going to go ahead and label the sides. Here's my hypotenuse. Opposite of the angle of reference, angle A, is over here, opposite. And adjacent is this side right next to angle A. All right, so which two sides? I'm trying to find an angle, so I need to know two sides. This side I know, and this side I know. And this is probably going to be written all over your papers as you keep doing trig. SOHCAHTOA. So which of these trig ratio uses opposite and adjacent? Well, tangent. So we're going to write tangent of, and you could either use A here or X. We put an X in the diagram, maybe I'll use that. So tangent of X equals the opposite side over the adjacent side. Well, the opposite side is 16 and the adjacent side is 20. Again, if we're trying to find, if it's saying tangent of a variable, we're not going to use our cross multiplying. We're going to use inverse trig. So tangent inverse, this is where we swap them around. So we do tan inverse of 16 over 20 is equal to X. And again, maybe putting that in parentheses is a good idea. So we're going to use our calculators and we're going to do the inverse tangent. Shift tan, parentheses 16 divided by 20, close my parentheses, and we should get X equals 38. And 660 thousandths when rounded. All right. Here comes the next one. I'm trying to find, again, angle A's measure. What is that angle measure, right? So based on that angle of reference, this is my hypotenuse because it's across from the right angle. This is the opposite side. This is the adjacent side. The sides I know are the 5 centimeters, which is the adjacent, and the 10 centimeters, which is the hypotenuse. A and H show up together, this time in cosine. So cosine of our angle theta is always adjacent over hypotenuse. Sorry, it's kind of messy. So we're going to say the cosine of, I'll use an A this time, cosine of our angle A is equal to the adjacent. Now, keep that in mind. Sorry, let's talk about this. So there are a couple of A's involved. So angle A is here, and then A we also use for adjacent. So just kind of keep things in mind that we have sometimes similar letters, but cosine of angle A is always adjacent, which is 5 over hypotenuse, which is 10. Since I know I can't find the cosine on my calculator of a variable, I know to use inverse cosine. So cosine inverse, I'm going to switch these around and compute that with my calculator. Inverse cosine, parenthesis 5 divided by 10, close parentheses. You could have also put in 0.5, and the cosine inverse of 0.5 is 60. So we get 60 equals the measure of angle A. So sometimes they are whole number answers. This is a 30, 60, 90 triangle. Which makes sense, right? Because we learned that the short side and the hypotenuse have that same relationship. Whatever this is times 2 gives us the hypotenuse. So we could have figured that out, but all right, next example. All right, so we have a word problem situation here. It says, you're building a track for a model train. You want the track to incline from the first level up to the second level. And this is 96 inches here, and this is 4 inches here. Find the angle of incline. So it shows you right here, X is this angle right here. We're trying to find how much does this go uphill, right? So let's go ahead and set this up. This is my angle of reference, the angle I'm trying to find. This is my hypotenuse. Opposite of that angle is over here, which leaves this to be the adjacent. The sides that I know are opposite and adjacent. Hopefully you're noticing that that is tangent. Starting to get used to that. So the tangent of x is equal to the opposite, which is 4, over the adjacent, which is 96. To find x in this situation, we're not going to cross multiply. We are going to use inverse tangent. So tan inverse of 4 over 96 is equal to x. We'll grab our calculator and use shift tangent, parenthesis 4 divided by 96, close your parentheses, and you get x equals 2.386. And the second part simply asks, is the angle less than 3 degrees? I think I might have missed a part of the directions. The question was going to be something about if the train can't handle more than a 3-degree incline, will this plan work? And the answer is yes, because it's only a 2.386 degree incline, so the train will be able to make it up the hill. So is the angle less than 3 degrees? Yes, it is.